rock layers and geologic history. Here we go. So here we have a cross-section of the Grand Canyon, and this is all sedimentary rocks, and they were, used to be sediments deposited on the ocean floor. They were compacted and cemented to become rock. And here we see all of these, very layer cake-like in this case. And the key thing here is the ones on the bottom is oldest and the ones on top is younger. So this was deposited, and that one on top, and that one on top, and that one on top, and that one on top. It's one of the key things about this. So generally, when you look at a cross section like this, it tries to give you a sequence of events: what happened first, what happened second, and the order. So a sedimentary rock's the lowest one. This is the oldest one, and then B. But there's something different here in that C is an igneous intrusion. Now, if that was igneous rock underground, that there was a lot of pressure, maybe pushed its way through a crack here, and then it pushed up layer D and flowed between D and B. Okay, so that was, think of really hot lava, underground magma. And one of the things, and you see it right here, contact metamorphism, when that happens, this is so hot that in the yellow here, that's contact metamorphism. It will metamorphose all of the rock that it touches, kind of partially melt it because it's so hot. A lot of times in geology, we say the word, it cooks the rock. Okay, that's kind of a phrase that often gets said. So it kind of cooks the rock. So what happens here is, so contact metamorphism, rock changed by high temperature. Okay, now that's going to give us some clues as to what happened here. So in this case, D, even though it's on top, is older than C. How do I know that? Because you can see that D has contact metamorphism on it. So D has been cooked by C. D had to be there for C to basically cook it. Okay, hopefully you see how that works. And that gives us the idea of the time frame here. So the first thing was A, and then B, then D, then C came. And so it's just sort of logic, this logic exercise. This is another question that comes up in cross sections like this. Name the rock that exists where C meets B. And I'm going to highlight what that is now. So that means anywhere here where C meets B. So C came in, it was really hot, and it contact metamorphosed B, kind of cooked it. So all of right along here is a metamorphic rock, the metamorphic version of rock B. So what's rock B? It doesn't tell you exactly. It says sedimentary rock. So you have to know, okay, to go to the sedimentary rock chart on the reference table, page 7. Okay, you have to find the symbol here, which is right here. It's sandstone. Okay, not your answer, because that was sandstone. What rock does that become when it undergoes contact metamorphism? Well, I know it's going to be a metamorphic rock. Let's go to the metamorphic chart. See, there's a lot to this, you see? So you have to really know how this all works. So hopefully you're paying attention. And kind of look around here of some under the comments. It says metamorphism of quartz sandstone. Okay, therefore it is this metamorphic rock, quartzite. Okay, and I wrote it in here. So it seems that there's a bunch of steps there, but no, that's how you're supposed to get to it. All right, let's do another one, because this is a common thing on tests. Name the rock that exists where C meets A. So similar question, I'm highlighting it there. So A is a sedimentary rock. I'm sorry, but it's metamorphic right there, and you go up close, you can kind of see how the crystals and grains kind of got melted together. So first, let's see what it does say. Sedimentary rock. Let's see what rock A is. So you go to the chart here, you look for the symbol, and it is this. Okay, it is limestone. So when limestone gets metamorphosed, what metamorphic rock does it become? Well, let's go to the metamorphic chart. And you really have to kind of look around here, and you're just kind of looking for limestone. And you'll find it here, metamorphism of limestone or dolostone. Therefore, that rock right there is marble in the blue. Okay, similar, but you got to work for it. You got to know where to look for these things. It can be a lot when you have to go to two different sections of the reference table, two different charts. So make sure you're on top of that. This one, it shows, and I hope that you can see this well, it is a photograph of a rock, of a section of bedrock. The photograph below shows an outcrop with two basaltic intrusions labeled A and B in a rock unit labeled C. So this is C right here, so this is the rock, and the intrusions are A and B. And here's intrusion A, and here's intrusion B, and it says, give the relative ages of these rock units from oldest to youngest. Okay, so the oldest one is C. That's the basic rock unit, because A and B then cut into it. Now, you can see, so C was there A came next, and then B cut across A. So B is the most recent thing, and I know because you can see B cut across A. All right? So it's the principle of cross-cutting relationships, we call it. So C is oldest, then A, then B, because B cuts across A. So I think usually, you know, we get a sense of that logically, of kind of how that works. It is more, it's a kind of a logic exercise in a way, if you think of it. Here, what we see a cross-section of rock layers here. Now, notice what I really want you to notice is this here, outlined in red. This surface here is called an unconformity. And because these layers don't conform to these. See how these are kind of wavy and these all conform to each other, but they don't conform to these. And what an unconformity is a buried erosional surface. So this represents that erosion happened here. There was a lot of rock that's been taken away. It's no longer there. And then B and A formed on top of it. So I think the best thing to do, I'm going to show this animation on unconformity formation right now. Okay, this is going to show an unconformity forming. So here we have, under the ocean, you see these sediment deposition, sediments building up layer upon layer. Okay, first one, second one, third one. Now, as this, they don't really show it here, they're going to get compacted, cemented, and form rock, so lithified into rock. Now it's happening, it gets pushed up above the ocean. It's no longer under the ocean. You have some folding here, and anytime you have land above the surface, you're going to have erosion. See the rivers here eroding it down and removes all of that land. And now all of this goes back down under the ocean, okay? Somehow it gets under the ocean, and then you're going to have more sediment deposited on top of it, like this. Okay, and you see those different layers forming on top. They're going to get deposited, and they're going to turn into rock also. And so the result of the animation is this. This is the unconformity right here, okay? And it shows that there was uplift, erosion, then it had to go back down beneath sea level for these layers to be deposited. So oftentimes there are questions like, what does that layer represent? What happened there, okay? So for instance, this is a good example. This is showing another outcrop here, and there's a lot of stuff going on. And the question is, identify two processes that formed the unconformity WZ, and they're calling it this line here. And the first ones that jump to mind are usually uplift and erosion, because it had to be uplifted above sea level. That's where erosion occurs. Underneath sea level, you have deposition. And uplift and then erosion. That is key. Other answers that would work, also weathering, subsidence or subsidence, which means once it's above the surface, going back down below sea level so that these can be deposited on top. That word works. And deposition of sediment as well, which would be these layers 3, 2, and 1. So those are other answers straight from the answer key of what terms would be accepted. So know those. This is another diagram just to show you how common this happens. And in this case, the unconformity is right here. And again, it represents erosion happened, weathering, uplift. Those are all important aspects to unconformity formation.